We're going to look at how to find a slant asymptote. Just as a review, finding vertical asymptotes, you set the denominator factors equal to 0 that don't cancel with the numerator. So in this case, x would equal 1. Horizontal asymptote, you have to look at the powers of the numerator and denominator. So in this case, the numerator power is a 2 and the denominator power is a 1, the highest exponent of the x's. And because 2 is greater than 1, that means there's no horizontal asymptote because the numerator is greater than the denominator. However, if the numerator is exactly 1 degree higher than the denominator, then there's a slant asymptote. And to find the equation of the slant asymptote, you need to divide. So we're going to do long division. Negative 3x squared plus, we need placeholders, that was an x squared. We don't have any just regular x's, x to the 1, so we need to add that in, 0x plus, and then our constant 2, divided by x minus 1. So you start by looking at your first terms. X times what is negative 3x squared? That's negative 3x. And then distribute. Negative 3x times x is negative 3x squared. Negative 3x times negative 1 is positive 3x. Then change the signs. Negative 3x squared plus 3x squared cancels. 0x plus negative 3x, or 0x minus 3x, is negative 3x. Bring down the 2 and start again. So look at the first term with the first term. X times what is negative 3x? That's negative 3. Then distribute the negative 3. So negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. Change your signs. Negative 3x plus 3x cancels. 2 plus negative 3, or 2 minus 3, is negative 1. Since we already have our constant up here, this is the remainder. So you put the remainder over what you divided by. For a slant asymptote, you don't care about the remainder. This is our equation of the slant asymptote. So then if we were to graph this, we said there's a vertical asymptote at x equals 1, no horizontal asymptote, but the slant asymptote is negative 3x minus 3. So the y-intercept, it's going to be a linear equation. So a diagonal line. Negative 3 is your y-intercept, and the slope is negative 3. So it goes down 3 over 1. So that's how your asymptotes end up looking. And then if you plot points and find the x and y-intercepts, you'll see that your graph looks something like this, which is probably unlike a graph that you've ever seen before. But just like with graphing other rational functions, if you're not confident in your graph, just keep plotting more points to check your work.